like how many customers will buy my product, or how many customers are looking into my TV shows. If let's say I'm from Netflix or Disney Hotstar, right? How to kind of create a research to understand that, right? So quantitative research methods, uh, qualitative we have discussed, open-ended questions, interview observations, audio-visual data, right? When we talked about ethnography, right? So you are not actually going asking questions, you are recording the, like let's say a lot of travel documentaries happen, right? So that shows that when a person is visiting a particular place, which are the area they are visiting, rather than going and doing a tourism survey. You can take that records of photos, take the records of videography, and try to understand or create a customer journey map of traveling, right? Text and image analysis, which is very much popular nowadays, because we have lot of algorithms, lot of natural language processing algorithm, which can analyze text and analyze the sentiment, right? Obviously there are obvious mistakes, because English language or any other language is a very complex, right? It took 1,000 years or 10,000 years for us to develop how to speak, how to write, right? In the last 50 years, but we have developed a lot of algorithm which can read and at least to certain accuracy predict what that line or what that paragraph talks about, right? Themes, patterns, interpretations, right? If you see in the pop culture, right, lot of things are changing. Any topic you take in the last 50 years, last 10 years, last 5 years, if I want to understand how this our behavior, attitude towards certain things has changed, you'll find a lot of changes. Think about how society, I'll not say it is fully open, but you must have observed like how things are changing. Basic things like uh, how much you spend in outside food 20 years back or 15 years back, right? Going out eating food was a luxury, right? And people used to like that, okay, every day you are eating outside. But now if you see, like most of the families are going to a McD or KFC and all those things. At least the middle class people or the people who were in the lower income group, that was the mindset that okay, that is a luxury and we should not go there, right? But now if you see, the consumption habits are changing. People, at least to have that experience in a month, or maybe in a 2 or 3 months, people even who cannot afford also, right, they want to have that experience, right? So those are the few things, it cannot be understood through a survey. You have to observe, you have to kind of record their experiences and think about traveling, right? uh, if you say in the last few years, traveling has become a mainstream, where it used to like, okay, if I go, I'll go to only religious places. If I go, I'll go to only these places where I can go and relax. But right now, if you see, a lot of people are going into adventure tourism, going to mountaineering, going to skydiving, right? So that mindset, at least in India, has changed a lot in last few years, right? So those few things, getting an answer from quantitative, right, getting understanding through quantitative becomes difficult. So when we talked about quantitative, that is something called predetermined. We have a understand the, okay, this is something I want to understand, and these are the few questions I am going to ask. So this is where instrument based questions, right? What is the definition of instrument or item? We'll discuss. Performance, attitude, observational, and sensors data. Sometimes, obviously, you can do observational. You need not have to go and ask questions if somebody is. And I think last class or in some class, I was discussing that. If I want to understand the problems customers face when they are going to a modern retail outlet, Reliance Retail or your Big Bazaar, what kind of challenges, what kind of problems they face, right? So you can go and do a survey. Rather than doing a survey, be a shadow customer, stand there or like act as a customer and observe people, observe the customers, how much time they have to wait in a waiting line. Let's say those products which are regular usage, somebody has put in a top sale, people are not able to reach that out, or people not are able to see that product, right? So those are the few things you will not know unless you can observe that, right? So sometimes quantitative also can be done through observational data. Mostly, obviously, we are looking to statistical analysis or statistical interpretation, because we are trying to make a judgment about the population looking into a sample number of observations, right? So before we get into the So basically, quantitative can be of two types, which is a survey research design. One is experimental research design. When you talk about experimental research design, uh, experimental research design is helpful when we want to understand the causal effect, right? So most of the times when you have used the regression, right, thinking that it is a cause and effect, right, our assumptions might be wrong, right? So dependent variable, independent variable, right? I say that okay, if I price, advertisement, messaging, uh, availability of distribution, all these are the factors which improve my revenue, improve my sales, right? When I say improve my sales, what I'm basically telling is there is a relationship, there is a relationship between these factors, this independent variable, with my revenue or sales or profit, whatever it is I'm going to measure. But when I say this causes that, right, uh, your let's say advertisement causes sales, right? So these two statements are different. When I say relationship, yes, both are moving in the same direction. If your advertisement budget or advertisement effort increases, there is an increase in sales. But when I say that advertisement causes increase in revenue, increase in advertisement cost, or increase in advertising effort increases revenue, so that statement means causal effect. So advertisement is causing your revenue, increase in revenue. So that condition, if I am telling about that, it has to have three conditions to meet, right? That is, X is the only cause of Y. If I say that advertisement is causing Y, so I have to prove that it is the only cause of Y, right? Which is very difficult. I can say that X and Y are related, correlation is there, and when X moves, Y moves, and how much it moves, I can uh, create a regression and say that okay, whenever there is a change in X, that much change in Y happens. Till that point, I'm okay. But when I say that okay, X is the cause of Y, I have to prove this. This is the only reason for Y, right? X must always lead to Y. That means obviously, when I say that advertisement increase in advertisement cost increases revenue, first advertisement should happen, then I'm measuring the sales, right? So that is a measurement problem, right? Otherwise, what will happen if I've taken revenue data from last year, previous year, and advertisement data of this year, and I'm trying to build a model, build a prediction, that won't give me correct results. So when I say that X must always lead to Y, how when I'm measuring makes very like kind of, that is very much important. It is possible to prove that X is cause of Y. So this is very difficult. Like I said, causal effect though we use in experimental design and we build our experimental design. Lot of healthcare research, right? Whatever we are studying or whatever we are going to cover today is like kind of almost, if you talk to any doctor, any researcher in healthcare area, same type of research they are going to do. 100% same type of research what we are going to discuss today, because research design remains same. Only their concern is, let's say think about vaccination, right? Whether by taking this Covaxin or Covishield, there is an improvement in, or kind of the person health is improving. Somebody who is affected by COVID or somebody who is not affected by COVID, if that person takes Covishield or Covaxin, the chance of that person getting a COVID problem is less, unless I can prove that, unless I'm certain about that, right? Obviously, nobody will allow me to sell my vaccines, right? Otherwise, like I do not want to name some persons, but there are some people who claim that okay, this will cure COVID, right? A lot of religious people started claiming that. Unless I can experimentally prove that, unless I can say that yes, I have proved to, so that. And how do you prove that? I'll go and put those vaccines for 100 people and say that okay, see, those 100 people did not have COVID. So because they ate my medicine, they took my medicines, they did not have COVID, right? So like that, if I allow everybody to prove their claim, or they claim that okay, they have kind of got a good vaccine, there will be 100 companies who can claim like that, right? So experimental design is statistical or mathematical method which follows a proper process. If I go through that process, then I have the result, then only I can come back and say that okay, this works or my solution works, right? So most of whatever we are going to discuss today is also applicable in healthcare research, right? Because the statistics or the mathematics part remains same, right? So the last step is very difficult to prove, right? Because think about any system. We as humans in a society, whether our society or our health system or our financial system, it is a complex structure, right? If I say that okay, there is a whenever international tension happens, there is an impact on stock market. That is true, but it might not be the only reason, right? There can be several other regions which are happening simultaneously, and that is impacting the stock market. If I say that okay, because my like kind of the celebrity who was endorsing my product this year, I have changed my celebrity, and that is why my product sales has declined. That might be one reason, but if I claim that this that is the only reason, I have to prove that there are no other reasons, which is very difficult, right? There can be several other factors which I do not have an idea of. The main distributor who was selling our product, they have declined, right? And when or he or that distributor is not, or retailer is not keeping our product, or competitor have started selling that product with 10% or 20% discount, right? There can be multiple reasons, which unless I prove that okay, those are not the reason of my decline in sales, how can I say that okay, this is the only reason of the celebrity, because celebrity endorsements has been changed, and that is how the sales has declined, right? So if I like kind of convert this into three statement, these are the few conditions of causality. Concomitant variation, it is basically the correlation. The two variables which I'm measuring, one dependent and other independent variables, right, are moving in the same direction, right? The variation or covariation are in the whether same or opposite. It can, I can always say that okay, if I reduce my advertisement budget, my kind of sales is declining also, right? Occur together or vary together. So basically, variation of together. Covariation is there in the way predicted by the hypothesis under consideration. The time order of occurrence, right? Condition states that the causing event must occur either before or simultaneously with the effect, right? That's why I tell whenever you are measuring any kind of variables, which kind of data you are taking. If I have taken the past year sales data and the advertisement data of this year, I cannot prove that advertisement is the one of the cause of increase in sales, right? Time order of occurrence means that when you are measuring those variables in picture, the absence of other possible causal factors, which, like I said, is very impossible in a social science sector, right? In healthcare or in any kind of scientific research, because you are carrying out those tests in a lab, right? Many things you can control, humidity, temperature, any number of factors you can control, and you can create an ideal scenario, right, to carry out this kind of research where I can say that yes, there are no other causal factors, right? But when you're doing a research in social sciences, a person might be unhappy while parking his car, and when you are taking a survey, he might give some different answers. Particular day, how that person's mood is, you do not have any control. You cannot have a experimental research doing there, right? So that's why whenever we talk about experimental research in social sciences, we have to be a little bit careful. Whatever claim we make on the causal sense, right, has to be with certain disclaimer that okay, these are the few things. Though we claim that we did experimental research, but in actual settings, it is difficult to prove, right? It is difficult to control those things, right? How a person answers, how a person's mood is, right? Lot of extraneous variables are there, you will not have control, right? And that is how in social sciences or the like marketing research, which is a part of social science research, it is very difficult to kind of have that kind of claim. Yes, yes, etc.
In some advertisement, right, like Horlicks or any health drink, sometimes disclaimer is put like among this number of participants we have tested, or sometimes like lab tested, like that. Does that means that we are conditioning, like we are controlling the conditions? So
Yes.
like this is the disclaimer they are putting. So how can we say that it is 100% effective? Like how they put the advertisement?
No,
Won't it clash?
that is why they put that disclaimer, right? Otherwise, some competitor will claim. Let's say Alex is claiming that if
Hmm.
continuously for 6 months or 1 year,
Hmm.
children between the range of 5 to 8 year old drink twice a day
Hmm.
Horlicks, their average increase in height is 3 centimeters more than those who take Complan, right?
Hmm.
They also know that it is not 100% accurate, right? Because
Achha.
same thing Complan can do and prove it otherwise. And that's why they put that disclaimer that okay, this research was done on a laboratory condition with 200 participants with these conditions, right? So that's why that disclaimer. Otherwise, if they don't put disclaimer, what it shows that it is true for all the population, right? Which is not actually true because
Okay.
there will be some other factors which they cannot control.
Hmm. Okay.
So today, basically, we're going to cover experimental research methods, like different types of experimental research methods. Once we cover the theory part, we'll come back and try to see that how to design experimental research. Like I said, conjoint analysis is one of the area which is used for this kind of, and mostly ANOVA, and one offshoot or one part of multiple ANOVA is conjoint analysis to like test or to design this kind of experimental research. So there are different types of experimental research. Pre-experimental research, where basically you do not have a random assignment. So when I like kind of discuss the example, that will be a little bit clear. Involves the inclusion of a single group of population that undergo treatment. It is always post tested, right? So what happens? You do not have a two different set of groups. So okay, before I come to this, let me just discuss what do I mean by experimental design and what are the symbols. So there are basically, whenever we talk about experimental group, there are two like groups, most of the times, not always. There will be one group of people which is experimental group, right? Who are going through certain conditions, and it can be anything. Let's say there are two groups of people who have watched my advertisement or who have visited my website, who have seen my blogs or content. So that treatment becomes treatment, not always, because in healthcare these methods came from healthcare. So that meaning of treatment is, let's say you have taken a injection or you have taken a medicine, right? So that's the meaning of treatment. But in social sciences, what do you mean by treatment? If somebody let's say have watched my advertisement, so he has gone through that treatment. Or if somebody has kind of, let's say, visited my website, gone through some of my whatever content I have put in my blog, right? So that becomes a treatment, right? So those people who have been exposed to the treatment, those are known as experimental groups, e.g., right? Control group, they are the ones, right? Those test unit not exposed to a treatment, right? So they have not gone through the, like, my whatever experiment I'm conducting. Maybe I'm carrying out for certain advertisement or certain discount, whatever from the marketing side, what you can think of. So let's say package design, right? So let's say I have two or three different packages to test. Finally, what kind of package my product will be, like kind of I'll production will go on. So finally, I have to finalize one packaging design. But right now, my designers have three designs or four designs, right? So if I want to understand, okay, this particular package, if I sell my product in this packaging, that is much more innovative, much more attractive, and more people will be attracted to buy this my product. Product quality, quantity, discount, price, everything remains same. Only changes the packaging, right? So if my original package, whatever it was there for the last 3 years or 5 years, I'm using certain kind of packages. So that is there. So that is the control group. Experimental group will be those people who have been gone to the market and seen my new package. So what is the treatment here? Though the treatment is by like kind of making sure that those people who are going to the Reliance Retail or Big Bazaar have seen the new packaging. So looking at the new package becomes the treatment for them, right? So treatment not in the sense of we are like kind of because it, like I said, it came from the healthcare or the scientific research. Treatment means you have done some let's say you have given an injection or you have given a medicine, right? Or you have done certain changes in the temperature you have changed, or some like kind of additional material you have put in that experiment. So in the social sciences, if the customer has gone through certain experience, right, so that becomes the treatment, right? R means the groups are randomly assigned, right? And that is very much important in experimental design, right? So, like Ekshita was asking, those children who have been like, if that advertisement shows something like that, can they prove that they have taken random children, right? Otherwise, what will happen? Those people, those children who have healthier parents, or maybe from a higher income background, have a healthy lifestyle, have access to medicines, have access to good vitamins, right? Obviously, they will have a better increase in height, right? So that is where random assignment is very necessary whenever I talk about experimental design. Not all the experimental design has to have a random assignment, but when I talk about the true experimental design, which I'll show you, when I say that yes, these are the conditions I have randomized, right? These are the kind of participant which are random to any group, right? Then only I can say that that is a true experimental design. So in the package design example, let's say experimental group is selected for the particular, let's say Reliance Retail, right? In one Reliance Retail, I will have a new package. So they will go through, and so those people for that 1 month, whoever is visiting that Reliance Retail, they'll go through that new package in another city. I'll continue with the same package, my existing package. So those people who are going through or looking at my new package, they become my experimental group. And those people who are not in my the control means no change, right? So they are there, they're going through the same experience, no change in their experience. Then I can measure that, and I can understand that whether there is a difference in treatment by putting my new package design, whether there is a change in cells, right? So this is how this is the basic designations or basic notations of experimental design. So, so there are basically three types. A single subject is basically whenever only you have only one particular resource or one particular participant, one particular. It need not be necessarily a resource or participant or human. It can be any company also, right? If I want to study a company, how a B2B company is performing, right? So that can be a single subject research method. So pre-experimental research is you are looking into a before your experiment happens, you are not measuring anything. So let's say there is a group of people who are taking a, like, let's say right now a lot of new dieting, lot of people who go through Instagram, or some of you might be following certain new diets also, right? Keto diet and all those things are happening. So what will happen? I want to understand the lifestyle changes or the like kind of improvement in their health, reduction in weight, reduction in blood pressure, right? So if those people follow through the 21 days or whatever the plan, 3 months of plan, and then I measure whatever the blood pressure or whatever the health habits, whatever the weight, right? So that becomes a pre-experimental research method, right? Before the experiment, I have not taken any measurement. Second thing is that I do not have any controller experimental group as such, right? Quasi experimental is basically, again, we do not have a random selection, because I'll show you when I talk about random selection, it is a very difficult kind of thing to do in social sciences or in marketing research. So quasi experimental is something close to true experiment. Only thing is that we do not have a random assignment, right? Or we look into a different time frame, that can be also quasi experimental. True experimental is somewhere where we have random assignment of people, random assignment of participant. Think about that question what Ipsita was asking. If truly I want to carry out a random or true experimental design for health drinks, as a company, what I should do? Let's say there are how many, like what, 5 crore or 10 crore children who are kind of my target customer, target consumer, who can actually like eligible for my study. Out of that, when I select, let's say 5,000 or 10,000 children, that need to be randomly selected, right? That means I should have a list of those 5 crore or 5 lakh customers. Out of that, randomly, by using a random number generator or by any other method, I should select 5,000 children of different income background, different lifestyle, different like kind of again like children's health also depends upon whether their parents are healthy or not, right? So all those factors combined, right? It should not happen that when I'm uh, putting the test or carrying out the test, one group of children have a better lifestyle, better income group, and when I test that, obviously that whatever height difference or weight difference will be completely different from other group of students, right? Other group of children. So that is where you have to make sure, if I'm talking about that, okay, this is a true experiment design. So in the experimental group and control group, right, equal assignment or random assignment of people has to be there, right? Random assignment of those children has to be there. Think about a vaccination, like right now whatever tested they would have done. If I just take healthy people and put them in my experimental group, and there are this, and that's why some like companies also cheat, some companies also do this kind of corruptions, like unethical practices, just to show that their product works. Think about the like impact of this kind of malpractices. So what I'll do, I'll take healthy people from the age group of let's say 20 to 30, 35, and that people only will be part of my experimental group. And those people who are let's say same age group 20 to 35 but have some health conditions, I'll put them into my control group. So control group are the group where I am not carrying out any experiment. I'm not providing them that vaccine or the medicine. Then for the healthy group, I put the medicines. For the unhealthy group, which is a non unknown to the anyone, I have designed my experiment. I have like put this kind of definitiveness, this kind of corruption I have done in my research design. So what now happens after they have let's say go to the real world and live for next 6 months? Obviously, because anyhow, even without my this intervention, without the putting of these medicines or the vaccines, very less people from the healthy group would have been captured cold or have been affected by COVID. Those people who are in the unhealthy group, most of them would have been affected by COVID. Then I'll prove that, see, they, because they have taken my medicine, they did not get affected by COVID. So my vaccines work proper. And so this kind of problem happens when you do not do. And if you are claiming like that, whenever that audit happens from the medical council, and they'll check that how do you show that this is the randomness? These people had earlier diabetes, blood pressure, and all those things, and those are the people who have taken in your control group, right? So this is why a random assignment of people participant into both of your experimental and control group is very much necessary, because that is something you will be asked, at least in the healthcare. Same thing in the advertisement also, right? If complaint is claiming that the advertisement council, let's say the other company put a case against them, so they have to show that, okay, so in the laboratory experiment whatever they have done, what kind of children they are taken, whether in the control group and the in your treatment group, experimental group, similar type of similar characteristics of children were taken. Otherwise I can take healthy children, those people whose parents are have a very good height, taller, I'll take them and put them in my experimental group. Those people who are whose parents are shorter or maybe do not have a healthy lifestyle, that those children I'll put in my control group. And obviously there will be 6 months down the line, there will be height difference. Whether they take complaint or not, that is different thing. There will be obviously height difference, right? So if I am doing like that, so obviously the other competitor might put a complaint, and necessary actions might be taken against the company, right? And that is where the experimental design, whenever I'm claiming something like that, I have to, and most of the claims happen, right? If I use this kind of Castrol makes those claim, many companies make those claim. If you use this will be 10% better than the competitor, right? I should have justifications for that, right? I should have, in particular these kind of cases, I should have done some experimental design or research. I should have documents to prove that, right? So let us try to understand different type of research designs. So remember the symbol, that is important. So again repeating, O is the measurement. When I'm talking about the O, right? I'm taking a measurement. X is when the treatment or exposure of treatment happens, right? Like I said, exposure can be some group of people looking at a new packaging, some group of people looking at your new advertisement, right? So that is nothing but a exposure to the treatment, right? EG, CG, I have talked about experimental group, control group. R is very much important, which is required for a true experimental design. R means the random assignment, right? Aim is obviously uh, the number of people or the characteristics has to be same, right? Equally. So sometimes it is a balanced group, sometimes it is unbalanced group. If my groups are unbalanced, I have to have justifications for that, right? Sometimes groups will be unbalanced, right? If I talk about something, I'm doing a research where I want to like kind of let's say understand the uh, how like kind of adoption of Instagram or adoption of let's say some this online payment system in different age groups, right? So that groups might be little unbalanced because no, those people who are little bit younger in your age group from 20 to 35 or 20 to 30, they might be using different kind of apps. Little bit older group who are let's say above 45 or 50, they, though due to last 2 years of COVID they have started using that, but they, the number of people who are using that in comparison to your age group will be still smaller, right? So when my groups are unbalanced, I should have some justification. Let's say I'm studying something comparing male and female, right? In certain areas the use like kind of female adoption of certain products are will be more. In certain areas male adoption of those products will be much more, right? So I have to have justification if groups are not balanced, right? When I say groups are not balanced, the number of participants in both the groups are not same, right? Uh, but most of the times, whenever I'm doing this research, ideally the group should be balanced. That means the equal number of participants in both control group and experimental group. If it is not there, right, I need to have justification. Okay, for this region, the like let's say credit card, right? Obviously if I'm taking three groups, income groups, less than 5 lakhs, 5 to 10 lakhs, above 10 lakhs, right? So in India those three groups will be unbalanced because less than 5 lakhs there will be maybe 60 percentage of the population, 5 to 10 lakhs maybe 35 percentage of the population, above 10 lakhs annual income maybe 5 percentage of the population, right? So when I'm taking some respondent, equally it will be unbalanced when in my experiment happens, right? So that is where, that is something you have to keep in mind whenever you are, let's say whenever you discuss about experimental design. So remember the measurement happens, right? X is the exposure to treatment, EGCG, I think it is clear. R means the random assignment of whenever R is not there, that means the participants are not randomly assigned. Then you have to question that whether it is a truly experimental design. So when you talk about true experimental design, R has to be there, random assignment has to be there. Okay, so one short case study, right? So like I said, you start a healthy diet for next 21 days and you measure your parameters, right? So and then you'll say that okay, due to this healthy diet, right, my like kind of breathing has improved or my energy level has increased, right? With a one short case study, test unit people, test market are exposed to a treatment. X means the exposure, right? X means like I said, treatment has happened, right? The standard notion of the treatment is the symbol X. A single measurement of the dependent variable is taken. So that is O1, right? O assume that measurement happens, right? So here what is missing? Before the experiment happened, right? If we do not have measurement, right? Generally, if it is a new product, right? You started a new product, obviously before that, that product, nobody will have awareness or nobody will have knowledge about that product, right? In those kind of cases we can carry out this kind of test where experiment X O1, right? Experiment is the exposure of the product, then how many people are buying it, right? So that is one short case study. Again, because R is not there, right? So this is not a random assignment. I put some test sample in the market, in Reliance Retail or the Reliance store, then observe that or then find out that how many people are buying that product, right? So people who are coming to Reliance Retail or the market wherever put, that is not in my control. That is that part I'm not able to randomize, right? So that is where X01. Clear or any doubt? Yes, Nilesh.
Could you please explain that one group pre-test, post-test?
Uh, yeah, so that anyhow I have not discussed. So one group pre-test, post-test is, let's say the same example. Before this, in a Reliance Retail, I have people who are purchasing some items. I started putting some discount, 5% in the product, or putting some offer, 10 gram extra, 20 gram extra if you buy this, right? So what happened? Now I know last month till last month what is the monthly sales of my product, right? So that is O1, right? So I take that measurement. O means measurement, right? I take one measurement. Measurement here is the sales. So measurement for 1 month of what is the sales are happening. Then I put a treatment. Treatment is X. X is here. Let's say discount is given. Whatever offer, some offer has been, sales offer has been provided. Now I measure. So that becomes my O2. Second measurement I'm taking. So if you see in the previous case, that is only one measurement, O1 only. Here I'm taking a two measurement, which is one is pre-test, one is post-test, right? And when I take, I can carry out a simple t-test and find out whether there is a difference which I can claim that that is applicable for the population. So one group, single store, pre-test and post-test. Before test, I take measurement of sales. Then let's say there is a package change, or let's say promotional change, or some advertisement change. Then O2, measurement of sales for the next month. So generally, we do not take for 1 month. We take for few months. Let's say 1 quarter, 3 months, same quarter, right? Otherwise, sometimes there is a seasonal effect also, right? Let's say if you go to the Diwali side, October, November, December, some products will be sold, right? Generally, you have to find out those neutral months in between, right? Which do not have a seasonal impact of on your product sales. Then you measure the sales difference, saying that whether that sales difference is actually true or not, right? Clear?
Yes, sir.
Then static group design, right? Static group design, if you see in this case, there is no definition of experimental group and control group. So you had only single group, single store where you were carrying out this test. Static group design will happen. Let's say I have two Reliance store. In one Reliance store, I put this new package design, that is the experiment X. Then I measure how many sales are happening for that particular month. In another Reliance retail, I have the same old package, right? And I measure how much sales are happening. So then I'll measure the two difference between two Reliance stores. Experimental group, those Reliance store where I have made the change in packaging or discount or any kind of advertisement, right? Any kind of promotions. In the control group, as existing, there is no change, right? So that is, for that to happen, at least you make sure it is different city, right? Because in the same city, same people might be going to two different Reliance stores, right? So if I have a store in Hyderabad and one is Pune, in Hyderabad I'll make the change, in Pune I'll not make the change, and try to find out the what is the difference, right? Then that is the static group design. So again, whenever you're talking about pre-experimental design types, in all these three, you see the symbol R is not there, right? So that means I do not have control. I do not have a random control over my participants, right? Who is coming to my store and how to control that? That I do not have any idea, or I do not have any control. So this is known as a pre-experimental design types. Any questions on this? Next is quasi-experimental. It is basically time series design. Again, there is no randomness. At least in social sciences, like I said, very difficult to include or bring randomness into picture. So time series, a single time series design. What I take data for few. So if you see, like in the previous case, we did for maybe 1 quarter or 1 month. Here, what happens? Multiple data points. because like I say, sometimes the trend or seasonal impact on sales might happen, right? So let's say I take data for past 5 months or past 6 months of the year, right, and make some changes, then make let's take the data for next 6 months. Same thing for your let's say Complan or Horlicks, right? So on an average monthly, what is the height increase, right? So January to January, February, March, April, May, June, let's say 6 months. So they measure the average increase in height, right? Then for that first 6 months, that person or that those children have not taken Complan. Then they started taking Complan. The experiments start happening. Now I start measuring from July, August, September, October, November, December, right? Then on an average, what is the change in height, right? Then I can claim that, okay, this is true for a length of period. In the previous thing, what we discussed in the pre-experimental, it is a one-time study only, right? You are not going to do the same test every month for freelance later. 1 month or 1 quarter, you did the study, whatever results you get, that's it. But here, for several months, in some cases, several years, in the particular case right now, the situation we are going through, actual results of this vaccine treatment will come after few years, though we are taking that vaccines. And that's why like kind of this medicine business is so costly. Truly to have the impact that, okay, I can prove that this medicine actually works without any side effects, it will take 8 to 10 years. It has to have a time series data. So for the 5 years, those people who have taken vaccine, is there any side effect, what is happening, right? So those people who have like kind of innovated or developed this vaccine, they are still doing those kind of experiments. So in multiple time series design, same situation, only thing is that you have a two different groups, right? So you have experimental group and control group. There will be few groups, let's say this vaccine you have been observing for next 1 year or 2 years, those people who have not taken vaccine. In Western countries like USA, Europe, there are some group of people who think that, who are against vaccine, right? So now you think about the infection, think about how many percentage of them are each month, each quarter, each year are getting like infected with COVID. Then some group of people who have taken vaccine, and what are their kind of changes in health, changes in like, is there anything, is there any side effect, right? Blood pressure, sugar, all those things, right? You are measuring. Then you can compare. So there are group of people who never took vaccines. So this is their health, this is their parameters, and these are the group of people who at a certain point of time have taken vaccine. These are the parameters, right? So then you compare. So quasi experimental, mostly two parts. It is still not randomized. Second is we are looking at a time frame, right? Not only a single time frame or a cross section, right? Any questions or any doubt on this? So now we come back to the last part, which is a truly experimental design, right? And that's why out of these three type of experimental design, only two experimental design, because I'm telling that, okay, the assignment of participants has been random, right? So post test only control group design, experimental group. So there is a R means a random assignment. Think about it, and most of the times in the website design, website research, Amazon, Flipkart, they do like, if you remember, we discussed something called the market testing, A/B testing, multivariate testing.
Yes.
So those people actually do this kind of random assignment because for them it matters a lot. So again, you have to remember, how do they make those random assignments? Because they have almost all our data, right? If I am a prime video, from my age, from my consumption habit, right, gender, location, and they will have cookies in my laptop or mobile phone, what kind of other sites I am visiting, almost all the information about our social media behavior, right? Instagram pages, how much time I'm spending on Instagram, how much time I'm spending on YouTube. Sorry, I got disconnected. Give me a moment to share my screen. Okay. So, like I said, most of these e-commerce companies, whenever they do this website testing, right, A/B testing or multivariate testing, they uh, kind of, because they have a lot of data, right? In a actual field setting, carrying out a true experimental design is very difficult. Think about Reliance Retail, right? How will I randomly assign, okay, you go to that store only, you go to this store? I will not have that control. But in a website, if let's say for like me, there are other people who are in the age group. Yes, or so there are other group in my age group, same social media behavior. So when I visit Amazon's page, I'll be shown certain web page, certain like kind of whatever the page, right? In my same age group, other visitors will have different page, right? And whatever my behavior, whether I buy those kind of product or put that in my cart, it will be compared to same age group, same behavior with my other kind of people like me, right? So because that part they can control, which website, which page to show whom, that part they can control, unknown to us. Same thing with any page you take in today's world. Carrying out this test has been over the years has been, earlier it used to be very expensive, so very few companies used to do that. Right now it is very easy. Even if I start a website blog and I take a subscription of this Google Analytics, and I can randomize which people will see my blog in a black theme, this kind of picture, which people will see my blog in a green theme with other kind of graphics, other kind of images, right? And I'll see that, okay, how many people are liking that post, or and what is the difference, right? And that kind of randomization is possible whenever we have this kind of website setup, which is not possible in a real field scenario, right? Somebody buying to our store, that part will not be able to control. So post test only. So randomly I assign two uh, groups. Let's say I have two pages, two website, or click to action button. Sometime in, let's say in one it is click here to subscribe. Second click to action is click here to get 10% discount, or click here to have a trial of 7 days, right? So let's say I have two call to action button. Click here to subscribe to my website or my blog page. Second is click here to have a 7 days trial of this whatever product or whatever service I am providing, right? So those people who are coming to my website per day, let's say 500 visitors or 1000 visitors, right? Randomly it will be assigned based on their viewing style, right? So remember that what actually we are randomizing. We are basically randomizing on the like social media behavior in this particular case. Because a lot of information about their income group will not be income group, their attitudes, all those things will not be available to us. But what we have available as a company, let's say website, mostly their kind of internet usage, location, their behavior on the internet, right? And that's why a lot of companies, whenever you go to any website, they will almost right now they're forcing you to accept cookies, right? Because once they put that cookies in your browser, whatever you do, whether even in the incognito mode, they will know that, okay, these are their behavior, or these are the website behavior. So post test only, it is similar to that one shot case study. Before experiment you do not have any data. After experiment, right, let's say I start a website, I start a blog, right? Like in the other case, pre-experimental, I'm creating a new product, I'm launching a new product. Before that I do not have data, right? Similarly, let's say I start a new blog or start a new service, right? I have two different web pages. Randomly those people who will visit my website will be assigned. I start a experiment. In one of my web page, there is a click to action button is click here to get a 7 days trial. In the other web page, only the subscription option is there, right? No other, no trial period and nothing. So in one web page, one version of my web page, there is option to 7 days of trial. In the other web page, it is normal. If somebody is interested, they have to pay money and subscribe. Then I'll find the difference. Okay, whether my difference in people who are interested in my web page or interested in my service is increasing by comparing how many people have gone for the trial and how many people have normally gone for subscription, right? So same thing, pre-test, post-test. So if you see this, the main difference between this one and what we discussed in the pre-experimental is what called R, right? In every case, we have the experimental group and control group, and participants are randomly assigned. Again, pre-test, post-test, I have an existing website, mostly let's say companies like Amazon, Flipkart, right? The web pages, I make some changes for certain group of people. I show that experiment. So they go through that exposure of a new web page, new design. Other group of people, they are existing. Whatever the existing web page, they go through that. Then I measure the difference, right? What are the difference? Okay, here O2 minus O1. Just a moment. So what are the difference between that in the experiment group after that exposure happens and the control group, whatever the exposure happens, right? And if I subtract from that, whatever in the exposure, so just think about this scenario. There are in the same web page for the same product, there are, let's say, on an average, every day there are 100 buyers who used to buy that product, just for example, or subscribe to that YouTube channel or subscribe to that service. Then I put that experiment. Then when I measure it, it has increased to 150, right? So before my experiment, there are 100 subscribers every day. On an average, there are 100 subscribers who are getting added to so on my Instagram page or my blog or in my web page. After my experiment, I made some changes, some new blog theme or new graphics, new visuals. It has increased to 120 on an average, right? So I will have the similar page, right? Which I'm not making any changes. Again, I am measuring. Then on the same, like maybe after few days or few months, again I'm measuring what are the changes. So let's say this was 80 or 60, then this becomes 70, right? So what happens? There is a trend line. That is because your word of mouth exposure of your blog, your website is increasing without any change in your visuals, without any changing in graphics. That will obviously increase in your subscribers. So this control group will be able to measure that. So it was 60 or 70, it became 80. So the trend of increasing of subscriber every day is 10, let's say, right? So O4 minus O3 will become 10. In the website or in the page where I make some changes and I'm showing to certain group of people, what are the change? 100 and O2 was 120. So what will be the difference? 120 subscribers per day, here 100 subscribers per day. 120 minus 100 is 20. So the treatment effect is actually 120 minus 100 is 20. Then here 70 minus 60 is 10. 20 minus 10 is 10. So the treatment effect is 10. Now the second step is that whether the 10 is significant or not. Actually, if I, because these are not all my website visitors, right? I'm just doing this treatment for 500 visitors or 1000 visitors per day, right? Whether it will be applicable for, let's say, overall visitors on internet 10 months down the line or 1 year down the line. Then if I can make that judgment where I'll do that t-test, right? And I can statistically with 5% significance, I can claim that, yes, this change of 10, 10 means how much? If my website visitors are on an average 100, so 10% change, right? Due to this treatment, due to this visual effect change, there is a 10% change in visitors, right? Can I claim that for my population? So for that, whatever we have studied earlier, right? T-test or ANOVA, those are the few tests we have to carry out. Is this part clear? Why this random and how it is different from your pre-experimental design? So next is again like sometimes what happens once a treatment happens, mostly happens in advertisement, right? People might kind of give different answers if I'm carrying out and understanding their behavior. So if I compare pre-test, post-test, I have only one single experimental group, one control group. Here I have multiple experimental groups and multiple control groups, right? So in the first case, what happens? Experimental group one, again, true experimental design means all those four groups, random assignment of participants. So in the first case, what happens? I take a measurement O1, then they go through that whatever visuals I have changed. Then I measure how many new subscribers, right? In the other control group, no change in visuals. I take measurement on an average, how many people are visiting my web page or taking subscription of my YouTube video or whatever blog or something. Then again I measure in after some few days or after certain time frame. But in the experimental group 2, right? So if you say this is a mix of post test only and pre test post test, what I do random assignment, I do not take a pre measurement, I just take post measurement. So experiment happens, I take a post measurement. Then in control group 4 also, there is no measurement, no experiment. I take a measurement after certain time frame. Remember that O3, O4, O5, O6 has to happen in a same time frame, in a same day or a same month. So the similarly O1 and O2 also, right? The measurement I'm taking in the same day, same time frame. It should not happen that O3, O4, O5, O6 when I'm taking that measurement, it is in different time frame, right? So what basically it shows that okay, it is used to when researcher suspects that earlier test influence the result of later test, right? Let's say when I'm putting an experiment, right? Some people will have exposure to that treatment, right? And mostly it happens in advertisement and all those things. They might talk to, or they might say that okay, hey, look at this meme or look at this funny page, right? And go ahead and subscribe that, right? But that experiment is only for limited number of people, right? So what might happen, the control group, some people also might be, without my knowing, might get exposed to the other page. Let's say I'm looking at some Amazon screenshot which is only visible to me, right? I take a screenshot and show that to my friends, right? So those kind of exposure actually in reality happens, right? Because social media is open, all these internet sites are open. So to avoid this kind of effect, right, what we do, we create. So here it is only 4 groups. Sometimes there will be 6 group or 8 group. We create different experimental group and control group and try to measure the difference between two. Right. So in this particular case, what will happen? Both experimental groups are then exposed to a treatment. Afterwards, both experimental and control group are measured. So now what I do after this experiment has happened, right? What is the change? What is the change in like behavior? Number of subscriptions have increased. For some group who are new, like who are never gone to a website, never gone to that kind of service, when I put that exposure, let's say somebody, let's say who has not, let's say never have gone through a health habit page, right? Habit stronger. There are a lot of Instagram pages, lot of websites on creating or putting those small habits, atomic habits in your lifestyle. So for those group of people, I put that experiment and now I try to observe their whatever behavioral change, right? I try to compare with those people who were earlier exposed and what are the change, those people who are never exposed and what was the change, right? So this is again little bit additional, little bit advanced than the pre-test, post-test. Out of all this, if you see, like most of the times we are focusing on this pre-test, post-test, uh, wherever I have only experimental group and control group. I randomly assign few people. So when I say few people, mostly our target customers, right? Not that few people means they are not my customers or they are not in my, they are never going to be my customer, right? And try to compare that whether there is a real difference between whatever treatment I am doing. Treatment can be any kind of sales offer, advertisement, content, right? In marketing scenario, these are the few treatment: price change, right? Product design change, packaging change, promotional change, all those 4 Ps. Or let's say for a airlines, whenever you are providing services, right? It can be about the people also, right? Think about right now Tata has taken over Air India, right? So how those air hostesses dress, how they greet people, right? That can be changed, right? And now you try to compare that whether number of visitors or how your website looks when you go and kind of book tickets in Air India page. Is there any changes there? The technological impact, whether they integrate that to your WhatsApp or any social media application, they kind of do a lot of social media investment to target few customers, right? Then they can compare what was earlier customer involvement, how many customers are like kind of willing to travel in Air India, and after these changes, how many customers now are willing to be part of or be the customers of Air India, right? So not only on the product side, in the services side also, like we can do this kind of test. Process change, let's say two-factor authentication, or let's say WhatsApp. Before those kind of security changes happened, how many customers are willing to chat on WhatsApp? After this two-factor authentication or security features came into process, so that is a change in process, right? So that is the treatment. How many customers are like increase? How many like users have added after change of this kind of features, right? That can be also a kind of a experimental design, right? But remember, whenever you talk true experimental design, that random assignment has to happen, right? Any questions on this? So think about a company called Beachwear. This I have taken from a blog, I think the rich article on Harvard. Let's say they have four prices, and this same type of study will do and use conjoint analysis for that, and I'll show you what are the steps, right? But today, just to go through the theory part. Let's say this is a B2B website, which is basically kind of a software product to other companies, right? So it is a business to business company, right? So they have different packages, $150 per month, 160, 170, 180. So what this show that in your website, right, there are two type of messages, right? One type of content is showing that lets you manage customers relationship in just minutes a day, speed of the software. Other thing is basically kind of a power, the amount of data the software can process. So what it is telling, Beachware can be expanded to handle a virtually infinite number of customer files. Think about as a CRM software, right? So promotions, in the call to action button, I have two different type of promotions. So 30-day trial without any credit card, without any kind of commitment. Or if you take like kind of buy Beachware now and receive our contact manager software absolutely free. If you buy this now, additionally I'm providing some other software, right? So these are my four. So if I look into the factor of price, how many labels are there? Four. If I look into the content or the messaging part, there are two, speed and power. If I look into the promotional aspect, I have two. If I take different combination, right, how many total combination of messages or packages will happen? 16. How it is that? Think about in this way. I take one website, one kind of web page showing that okay, my price of my product is $150, and this message will be shown, speed or 30-day trial will be shown, right? So that becomes one option. Second option can be $150, it is showing same content, speed, but the other free call to action button, right? So like that, if you see, price 4 labels multiplied by message 2 labels multiplied by promotions 2 labels, there are 16 total combinations which are available, right? So I can expose different 16 different type of pages I can create and show to randomly show to different customers and try to understand how many like kind of which like offer or which package is working best for me, right? But just think a scenario here, it is only 16. Think a company like Amazon, the number of kind of options they have, how many categories they'll show, uh, what will be the price point of different product, what will be the like kind of different images they show, what kind of different offers they show, right? So if I multiply that, it will be a million number of combination, right? Which is not possible, right? If I start to create million versions of my website, it will take a lot of time even for a company like Amazon or a Flipkart, which have a lot of kind of bandwidth, lot of resources to work on, right? So this is where how you design your research. In the previous slide, what we'll discuss the types of research. Now the part is where you design the research, how to reduce this many options, right? So in this particular cases, rather than a company creating 16 different versions of web pages, then showing to customers, right? And to trying to find out that which offer will work better. So that is something known as, we'll discuss this later on, fractional factor design. There are 3 or 4 types: um, randomized block design, Latin square design, fractional factorial design. Mostly like kind of what we'll use in fractional factorial design in conjoint analysis. So what it shows here, if you see, I have this 16 combination, right? Promotions, message, price, right? So what it shows, there are 16 combination of my web pages which I can create, possible combination 16. Out of that, when actually I'm doing the design web pages, rather than 16, by using this fractional factorial design, what is that and how to do that, I'll show you using software. I'm actually creating 8 web pages, right? Not 16, right? I'm creating 8. And when I show that to 8, 2 different, like I said, randomly customers who are visiting my web page, few customers will look into this option, few customers will look into the other option. Like there are 8 options. So randomly I assign that customer. Then I found out that what are the subscription rate. So for the option which is price one, that is $150, message one, and promotion one, right? So there are 14% subscriber. The most famous one was price one, promotion two, message two. So what was my message two? Power, that it might like kind of lot of customers can be handled. Second is free gift. So promotion two, message two, and price one. So $150 per month, whatever the software, then with a free gift and ability to handle numerous infinite number of customers. So whenever I'm putting my web page in that, there are 40% subscription, right? So like that, the other numbers are given. So by using logistics regression analysis, I can estimate what will be actually for the other options, because see, I'm interested in all the offerings. I'm interested in all the combinations, not only in this 8 combinations. This 8 combination, why we are doing? Because building 16 web pages is more difficult than building 8 web pages, right? So I have to reduce my effort in experimental design. So from 16 web pages, actually I'm creating 8 web pages, showing that to my customers, looking into their response. Then once I have the data, right? So in a pro rata basis, I'm able to estimate or predict what actually would have been a scenario if, see, price one, promotion one, message two, that web page I have not created. But by using experimental design, I can predict if price one was there, promotion one offer was there, message two was there, around 23% of customers would have chosen my product or subscribed to my product. So if you see in this particular case, with a price one offer, around 42% of the customers are willing to buy your product, right? Or kind of subscribe your product, right? So which was anyhow in the price one also, like in the experimental design also, you come to. So the idea of experimental design is, by like kind of exposing customer to different type of treatment, I want to understand, by putting that effort, putting that change in packaging or change in pricing or change in my promotional messages or change in my process or change in my people's habit, right? Is there any impact in whatever impact I want to study? Mostly, if I look into marketing, 99% of the time, what impact I want to study is what will be increase my revenue, or what will be increase my subscription, or what will be increase my profit, right? So that is my ultimate goal. The idea is putting that effort, putting that advertisement effort, promotional effort, or packaging change, or pricing change, or product change, whether actually it is a real impact. Can I predict the real impact of that, right? So this is where your experimental design comes into picture. Any questions on this? We will do a real case study using this kind of setup, using conjoint analysis. But the real methods remain same, the process remains same. Only thing is that we'll try to do it using a software. Okay, so that's about your experimental design research. After next class, we'll come back and try to do a case study on that. Okay, so any questions which we did not discuss, or you are still confused on experimental research? Okay, so survey research, there are again two types which we discussed earlier, cross-sectional and longitudinal. Cross-sectional is all information collected at once. Any survey, at least in this class or most of the times whenever you are carrying out any project, right? We collect data only once, right? So that is where your cross-section, different people, different combination of people, but you are collecting data only once. Longitudinal design is divided into three types. One is trend study, one is cohort study, one is panel study, right? Uh, we will try to understand through an example. Hmm, think about that same example what we discussed in the beginning. That question came, right? Health drinks, right? Children, what is the impact of health drinks? Regularly, if children consume 2 times a day, 5 to 8 year old, right? We want to understand for that age group, right? So let us try to understand through a trend study. Members of population can change over time without affecting the result, right? So what happens? So those people, like let's say I want to study for next 3 years. So 5 to 8 year old group. So what will happen? Those people who are 8 year old, next year they'll move to 9 year old. So they are not my population right now because they have changed. Similarly, those people this year who were 4 year old, so they have become 5 year old. So they will become part of my population, right? So when I'm next year, when I'm doing a study, there will be few people, few children who will no longer be part of my study because they have moved out of my population. Those children who were 8 year old this year, they will become 9 year old, right? Because my study I'm only looking into children who are 5 to 8 year old, right? So next year when I'm, let's say this is a longitudinal study for multiple number of years, right? 3 years I'm want to do the study of the children group of, or the age group of 5 to 8 year old, right? So what will happen? Next year those people, some children will be out of my group, out of my population. Some new children will enter my population which I want to study. Those 4 year old, those children who are 4 year old, they'll become a part of my population, right? So this is where your trend study comes into picture. I'm looking only into the groups, right? New people, new children can enter. Some children can, or some group of any age group you can think of, right? Thinking into the internet adoption of 60 to 65 year old. Those people who are 59 year old, next year they'll become 60 year old. Those people who are 65 year old this year, they will become 66 year old. So as per my survey criteria, they will no longer become my part of my population. Cohort study, it is possible to selection of different sample, right? Members of population cannot change. So what happens? Those particular group of people, but next year when I take, I'm changing my sample. So think about in this case, uh, MBA, like I'm doing this study for 2 years. Though last year, out of those 350 students, I study some behavioral, some attitudes towards your online education, right? But my 350 students, so those, my population remains same. 2022, 20 MBA School of Management. Those 350 students remain same. That is my population. But last year I would have selected 50 student or 60 student. This year I select different 60 student, right? My population remains same. So members of population cannot change. In the trend study, members of population are changing. In a panel study, so but what happens? My sample is changing. In a cohort study, last year I took 60 people, let's say from section A. This year I took 60 people from section B, right? So that can change. In a panel study, same sample always, right? So whatever I had taken, so that will remain same group of people, right? Think about the previous trend study what I talked about, right? 5 to 8 year old, right? But if I'm doing a panel study, what will happen? Next year when I'm doing a study, those children who are kind of become 9 year, so they will get removed from my study, right? So this year, if I have started the study with 10,000 children, out of 10,000 children, there are 2,000 children who are 8 year aged, or 3,000 children who are 8 year old. Next year, when I do the study, so those 2,000 people or 3,000 people will be out of my panel, right? So my study size or the sample size will become 7,000 next year. right? So is this clear? What are the differences between these three? Because cross-sectional, anyhow, you know that you are collecting data only once. What is the difference between a trained study, core study, panel study? Trained study where your population is changing. Core study and panel study, you are not changing your population. In core study, your sample can change. In your panel study, your sample will remain same. So sample will remain same means sometimes, let's say you are doing a study for some 65 to 70-year-old group, right? Some people may die, right? In between you do study for next 2 to 3 years, right? So there might be loss of sample, right? Because in this kind of trained line study, whenever you are studying something related to age, right? Age keeps changing, right? You will not be able to keep it same. So in that some cases, those people or those participants will might move away from your sample. Clear or any doubt? Okay, so we'll stop here for today. Next class we'll discuss on the survey research design. Basically today we'll discuss about the experimental research design. Next class we'll discuss on the survey research design, and after that we'll come back and start the statistical analysis part. Any last question before we close it for today? Okay, if not, chalo, take care. Meet next class.